All right, Tuesday for academic. So starting with a warm-up is a review from yesterday. Pause it, see if you can figure it out yourself, and then play when you're ready. All right, as we learned yesterday, we are trying to find M. M is the same thing we said as rate of change. It's also known as slope. Okay, and some different ways you can find it. You can either do the change in y over the change in x, or you can do rise over run. Okay, you'll probably hear me talk about it in this way a lot. Me personally, other teachers do it different, so just whatever floats your boat. Okay, so if we're trying to find that change in y and change in x, remember there's a couple of things you can do. You can do the rise over run situation. And remember, I think we did a problem like this yesterday. If I'm going from this point to this point, the rise is the up and down action. So since I am moving down, that is going to be a negative rise. It's going to be a -3. Then I'm running, okay, from 0 to this point. So that's a run of +30. So again, rise over run would be -3 over 30. I can divide both of those by 3. So be careful here. Negative divided by a positive, signs are different. So negative wins it. That's going to be a -1 on top and a 10 on the bottom. Okay, that is my M. Or you could have also said -0.1. Okay, my preferred method, again, this is just me personally. It's not right, it's not wrong. Or sorry, it is right, but it's not wrong if I do it this way. Is I like to find the points on here. So the ordered pair for this first one, I didn't move left or right, so that's going to be 0. I moved up to 10. Okay, this other one, I moved over 30 and up 7. Excuse me. I personally really like making charts. So X and Y, and then I put my ordered pairs in there. So that first one would be 0, 10, and then 30, 7. Okay, finding the more of this style, change in Y. Okay, I am subtracting 3, so I'm going to make sure I put -3. My change in X was +30. So you'll notice I'm going to get the same thing. If I put the change in Y over the change in X, that's -3 over 30, and it would simplify again to the same thing. Okay, so that's just a review. Finding M, that means we're finding the rate of change. Okay, I also noticed that in this, it's a negative slope. And so how that changes it is it's going down. Okay, it's a downward facing slope. That's what negative numbers do. Okay. This is going over homework. That would be something to ask about during tutorials. Just a couple ones that I do want to point out. On number 4 from Monday's homework, this was not linear because I see like a bend in that line. It doesn't make a straight line, so there is no constant rate of change. You might have found the rate of change from here and the rate of change from there, but it's not going to be the same one, so it's not a constant rate of change. Okay, so for today's lesson, again, I hope you print it out, and if you need to copy into an ISN, you can do that. Of course, pause and play as you need. Okay. As I mentioned in class last week, there's like additive relationships and multiplicative. This lesson, we are going to be combining the two with 2 steps. Okay, so a great example is from the homework. Let me erase this. I was talking about it in one of my earlier classes. Okay, it's combining the 2. So if on that number 7, if I tried to find the relationship, okay, I would be like, oh, they're adding 6. Well, if I tried to do that on the other ones, it doesn't work. 3 plus 6 is an 11. Okay, so, okay, it could be multiplicative. 1 times 7 gives me 7. So I tried times 7, but that didn't work either. Okay, so this is a great example of a 2-step equation. Okay, if you graph out these points, it'll be a straight line, and it has a constant rate of change, but it actually takes 2 steps. If you remember, our rate of change is our multiplier. So I'm going to multiply x by this. Okay, if I'm doubling 2, 1 times 2 would give me 2. To get 7, for this to equal 7, I still need to add something. If I put in 1 for here, I need to get out 7. That means I would still need to add 4. Okay, and so we're going to practice this relationship. If I you'll see if I plug in 5, 2 times 5 is 10 plus, what did I do? Oh, plus 5. Plus 5. Okay, so again, 2 times 5 is 10, plus 5 is 15. If I plugged in 3, 2 times 3 is 6, 6 plus 5 is 11. 1, 2 times 1 is 2, plus 5 would give me 7. Okay, we're going to practice these two-step equations in today's lesson. Okay, so hopping right in. If you're an ISN type of person, this rectangle, this box is a very important thing. I would copy it down as we go. Okay, this is going to be the step-by-step how to find, how to write your equations from a table, from a graph. Okay, we always want to start with identifying your rate of change. Okay, I will use ROC, rate of change, just to abbreviate. Okay, and that's what we practiced yesterday and we'll continue to practice today. Remember this, the way that we find this is we find the change in Y over the change in X. Okay, when I find that value, it is going to be my multiplier. In this equation from yesterday, M, the multiplier, that's my rate of change. Okay, after you find your rate of change, and multiply it by X. If you don't get your Y value, so like what we just saw on that homework question, if I tried multiplying but I didn't get the output, you need to think, okay, what do I need to add or subtract to get there, to get that output? Okay, and that's going to be what goes in this place. Okay, that value is called your Y-intercept. Intercept. Okay, intercept means where it crosses over the Y-axis. Okay, so again, this formula right here, it's on your 7th grade star chart. It's like your home base. It's your, we call it a template sort of, or a parent function. Okay, it's what you go to every single time, and you just plug in a number for M, you plug in a number for B, and you're good to go. Okay, just reviewing what each letter means though, because it's like it's a scramble of letters. The Y, as before, is our output, and that means X is our input. Okay, we just reviewed M in the warm-up. M is talking about my rate of change or your slope. And then B, again, is what I add or subtract, which is our Y-intercept. Whoopsie, I don't know what happened there. Sorry about that. Okay, Y-intercept. All right. So let's practice that. Okay, we're going to sort of warm up. We're going to do a few 1 steps and then we're going to get into 2 steps just so we're comfortable. Okay, I am going to skip around in these notes. So if you printed it out, we're going to go to the 2nd page. I'm going to skip and we'll come back to those graphs. I like to work off of tables. Okay, so again, on those steps, I need to find my rate of change first. So from a table, my rate of change, I want to find my change in Y over my change in X. Okay, independent is my input, which is my X. Dependent depends on what I put in, that is my Y. Okay, so we need to figure out what's happening each time. Okay, from 0 to 12, plus 12, 12 to 18, that's only 6, that's 6 again, and 6 again. That one's weird. Okay. Okay, that's plus 2, plus 1. Okay, so those are okay. So remember yesterday we said constant rate of change if it's not the same, but they're both different. So let's see. Okay, again, rate of change is the change in Y over the change in X. Okay, so the change in Y. For that, I'm going to see if it's the same. Okay, 12 is the change in Y for this first one over 2. Now, if I simplify that down, 12 divided by 2, I can get that down to 6. Oh, okay, maybe I can get this to be, I want to see if it's the same rate of change for these other ones. These are all 6 and 1. So if I do this change in Y over this change in X, that's 1. Okay, so it's still constant. It's just they sort of skip the 1 value. That's fine. Okay, no matter what, my rate of change, my M, was equal to 6. Okay, so again, if you remember, rate of change is my multiplier. If I put in that equation, the Y equals MX plus b, that's going to be the m. Okay, so I'm going to put in y equals 6x. But I want to check and make sure I don't need to add anything. See, it says, wait, let's check with the point. Okay, it doesn't matter which point you use. I'm going to pick a random one. Hey, look, 4 and 24. If I put in 4, do I get out 24? If I do 6 times 4, do I get out 24? I do. Okay, so do I need to add and subtract? No, I don't. Okay, so go ahead and try with that next one. Again, you want to make sure you check with your rate of change and plug a point back into that equation. Pause and then play when you're ready. Okay, finding the rate of change. Each one was plus 1. Each one was plus 1 again. Okay, rate of change, again, is the change in y over the change in x. Well, they're the same number. 1 over 1 simplifies down to 1. My rate of change is 1. Now let's check that. If I put that in as the multiplier, y equals mx plus b, that's m. Okay, well, that's not really going to change anything. If I put 1x, that doesn't actually change anything. No. Okay, I don't actually have to write that 1 there, and you'll see that we don't in junior high math. Writing this is the same thing as just having the x there, because it doesn't actually change the value. So we need to check with a point. If I put in 6 to this equation, am I going to magically get 10? No. If I put in 6, how do I still get to 10? What do I need to add or subtract? It's getting bigger, so I need to add 4. Need to add 4. Okay, so my equation is going to be plus 4. Okay, sort of kind of getting the hang of it. All right, so let's go back to the graphs now, back on that front page. I just like to get an idea of how it's going to go. Okay, so it's going to be the same steps as before. I want to find my rate of change and then plug it into the equation. But we have a graph, so okay, I don't have any points. I need to make them up myself. Okay, I get them from this line. So you can find wherever it crosses nicely, like right there. Ooh, that's nice. I also see it goes through the origin. Okay, so for the origin, if I wanted to get some points for that, that's going to be 0, 0. I know that. That's a 0. Okay, this one over here, I go over 4 up to 4, 2. If you want to throw another one in there, you can. Okay, so over 6, and then up, that's halfway. That's going to be 3, 6, 3, just if you want to. Okay, so finding that slope, I can put those points into a table. So I can put in 0, 0. I can put in 4, 2, and 6, 3. Oops. Okay, so if I find the rate of change, again, that's the change in y over, hopefully you're saying this to yourself, the change in x. I already know this. You have to practice that. Okay, change in y, that's adding 2. That's, oh, that one's weird, but remember these two are closer together, so that might be, that's adding 4, adding 2. Okay, so be careful. Again, we want to look at the change in y first. That goes on top. So I'm going to put that 2 over 4, which simplifies down to 1/2. And you'll see 1 over 2 is the same as 1/2. My rate of change, my m, is equal to 1/2. So let's plug that into that parent equation. Y equals mx plus b. The 1/2 is going to replace this guy. Y equals 1/2 x. Okay, but remember, I have to check. Do I need to add or subtract anything? Okay, pick a point, any point. Let's do this guy. If I plug that in, 1/2 of 4, do I get 2? I sure do. I don't need to add anything. Okay, so again, try it on your own, pause, and then play when you're ready. Okay, I'm going to use, you might have used different points. I'm going to use this one right here and this one right here. Okay. Ooh, this, we had in class, we had some mix-ups, so I would just want to refresh. When I do x comma y, x is talking about side to side, y is talking about up and down. So if I'm looking at this point, first, am I moving side to side? No, I have 0 movement side to side, but I did go down, so I did go -2. Okay, try it again with this one. Again, side to side. Yep, I moved sideways, a +2. Did I move up and down? Nope. So that would be 0. Again, you could have used different points, but those are the ones. Okay, put it into a table. Again, I only need 2 points to find the rate of change. Okay, 0, -2, and then 2, 0. Change in y. Oh, it went from a negative to a positive, so that's increasing by 2. Again, that one's also increasing by 2. So when I do my rate of change in y over the change in x, we simplify down to 1. Ooh, and we just did a problem like that. That means that when I do y equals, I don't need to write 1x. I can just put x. So that's already giving me the, did I get there? If I put in 0, do I magically turn that into -2? No. Okay, I need to add something. What do I need to do? I'm not adding because I'm getting smaller. Ooh, I maybe subtracted. Okay, let's try x -2. Subtract sub 2. Okay, let's try that. If I put in 2, 2 minus 2, does that give me 0? Yes, it does. Okay, so make sure it's -2. I had some people put +2 in my class today, but I'm decreasing as I go. All right. Okay, so let's look at these questions down here. Oh my gosh, my thing is scrolling so weirdly. Sorry about that. Does this equation work? Oh, we already talked about that. That's what we did, but let's look at this one. What do you notice about the y-intercept? Where do you see it on the graph? Okay, let's review. Y-intercept was b, okay, in the equation, b. It's whatever I add or subtract. Okay, so in this one, this is my y-intercept. Y-intercept. It's -2. So what do you notice about the y-intercept, and where do you see it on the graph? Where do you see it? Oh, hey, it's right there, -2. It's where the slope, the line hits that y-axis. It's the intersection or intersection of the y-axis. Okay, well, what about over here? What did I add or subtract? I added 0. I didn't add anything, added 0. Okay, and that's why it goes through the origin. So my y-intercept is at 0. That's why I'm adding nothing. Okay, so what you can write, what do you notice about the y-intercept? The y-intercept in the equation is where the line in the graph crosses the y-axis. Okay, so again, that -2 is right there. Okay, let's keep pushing through. Okay, we're going to do some 2 steps. So those problems we just did were either 1 steps, adding, or multiplying. We're going to spice it up, but we're going to go back to that home base. Okay, sorry, to flip around. We're going to identify our rate of change, then figure out if we need to add or subtract anything. Okay, so again, I'm going to start with the tables because I'm just personally better with those, and you will be too. Okay, first I need to find the rate of change, which hopefully we know is change in y over the change in x. What is changing each time? That's +9. Oh, yep, +9, +9. What's happening here? +3. Same thing. +3. Okay, so that was 9 change in y over the change in x. 9 divided by 3 is 3. My rate of change is 3. Now again, put that into y equals mx plus b. That's my y. Y equals 3x. Okay, check with the point, see if I need to add or subtract. So let's pick a point, any point. I'm going to do this one. Okay, if I put 3 times 3, do I just magically get 5? And no, miss slide. Okay, I still need to I need to subtract how much? 4. Okay, so I need to do 3x minus 4. Okay, and if you notice, again, on that y-intercept, wherever x is 0, I don't move sideways, it's at -4, and that's where it ties in right there. Okay, so try that next one, pause, and play when you're ready. Okay, rate of change, that's increasing by 1 plus 1 plus 1. This is increasing by 2. Okay, when I find the rate of change in y over the change in x. Now be careful, again, independent input x. Dependent is my y. The change in y was 1. The change in x was 2. Rate of change is half. So I'm going to start with that. Y equals 1/2 x, but I'm going to check it with a point. Pick a point, any point. I'm going to choose this one. Oops, sorry, that's a 2, 3. I just scratched all over that. If I put in 2, if I do 1/2 of 2, do I magically get 3, or do I need to do something? Half of 2 is 1, so to get from 1 to 3, I still need to do plus 2. Oh, I'm going to put that there, but I'm going to check. Let's put in 8. Half of 8, that's 4 plus 2. Yep, that gives me 6. You can check with all of them. Half of 6, that would be 3 plus 2 would give me 5. Okay, it just keeps on going. Okay, and of course I can do that from a graph. Again, I'm very comfortable with tables, so I'm going to try and put some of these points into a table. But pause before we do that. I want to see what is the y-intercept before even solving and being like, oh, what do I need to add or subtract? What do you see the y-intercept is going to be? Where do you see it? It hits right there, and that would be that 0, 1, 2, 3. So theoretically, in my equation, I should be adding 3 because it's a positive 3. But of course, we're going to check. Okay. Again, I know that's going to be 0, 3 because that's where x is 0. I didn't move side to side. It intercepted. Let's do this point. That looks nice. Okay. So 1, 2, 3, and up 9. 3, 9. X, y. Putting in 0, 3, and then 3, 9. Okay, change in x was plus 6, change in y plus 3. Change in y. I always write this out so I don't forget, it will mix things up. Change in y was 6, change in x was 3. That simplifies down to 2. So theoretically, if I put in that for m, that for b, y should equal 2x plus 3. But of course, we're going to check. Okay, plug in this number. Plug in 3, see if we get 9. 2 times 3, that would be 6, plus the 3. Does that give me 9? Sure does. Okay, again, do that last one, pause, and then play when you're ready. Okay, again, I see my y-intercept. It hits it right here at -1, so I'm going to be subtracting 1. Okay, again, that ordered pair, I didn't move left or right. I moved 0, but I did go down 1. I can do this one. I went over 4 and up nothing. 0, -1, 4, 0. Okay, finding that change. It went from a negative to a positive, so it's increasing just by one little hop. And then that's plus 4. So change in y over change in x, 1 over 4. 1 over 4. So theoretically, again, that's my m. This is my b. Y is equal to 1/4 x plus, oh, nope, not plus. Because it was minus 1, negative 1. Okay, of course we want to check. Let's check with 4 comma 0. I did 1/4 times 4 minus 1. Do I get 0? 1/4 of 4 is 1 minus 1 is equal to 0. Okay, so if you got lost anywhere in there, I might suggest like go listening to me explain it one more time or coming into tutorials. Any problems that we skip, that's going to be like classwork, it's going to be homework probably, and definitely check the key. Again, this is probably a little bit more high speed than you were used to, so make sure you're practicing and checking. Thank you, and goodbye.